Hi guys, our topic for today's video is all about binary code. So first, what is binary code? Binary code is a way of representing data using only two symbols, 0 and 1. These two symbols called bits, short for binary digits, form the foundation of how computers process and store information. Since computers operate using electronic circuits that can be either on or off, binary is a natural language for them. So, how binary code works? Bits and bytes. A single binary digit, 0 or 1, is called a bit. A group of 8 bits is called a byte, which is a standard unit for storing information. So guys, let's compute decimal to binary and binary to decimal. Okay, so let's start computing decimal to binary. So, una, kukunin mo natin ang value ng uh, per bits sa isang byte. So, ano ba ang una nating gagawin? So, uh, una, 1, 1, dodoblihin ang 1, magiging 2. Dodoblihin ang 2, magiging 4. Dodoblihin din ang 4, magiging 8. At dodoblihin natin ang 8, magiging 16. Dodoblihin din natin ang 16, magiging 32. Dodoblihin natin ang 32, magiging 64. Dodoblihin natin ang 64, magiging 128. So, this is the value of 8 bits in 1 byte. So, ipagpalagay na lang natin 78 ang kanyang decimal. 78. So, ano ang mas mababa sa 78 na number? So, itong 64. So, ibabox natin siya. Then, kukunin natin ang 64, ima-minus natin sa 78. So, 78 minus 64 is equals 14. So, ano ang number na naman na mas mababa sa 14? 8. Ibabox natin siya. Kukunin na naman natin siya at ima-minus din natin sa 14. So, 14 minus 8 is equals to 6. Kukunin na naman natin ang mas mababang number sa 6. So, ito ay 4. Ibabox din natin siya. Kukunin at ima-minus sa 6. So, 6 minus 4 is 2. At kukunin din natin ang number na mas mababa sa 2. Kung parehas lang sila, then ito na. So, kukunin natin. So, ibabox natin and minus then equals to 0. Lagi nating tatandaan na lagi siyang mag-e-end sa 0 or 1. So, ang 0 kasi ay off. At ang 1 naman ay on. At kukunin natin ang binary ng decimal na 78. Kaya ito na. So, ang 1 wala siyang box, 0. Ang 2 meron siyang box, 1. Ang 4, 1. Ang 8, 1. Ang 16 wala siyang box, 0. 0. Ang 64 meron siyang box kaya 1. At ang 28 naman ay 0. So, the binary of 78 is equal to 0, 1, 0, 0, 1, 1, 1, 0. So, lagi nating tatandaan guys na ang binary of 78, lagi nating tatandaan na ang binary is equal to 8 bits. So, 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. At itong bits na to, 8 bits, itong bits na to ay equivalent lang siya sa 1 byte. Okay. So, Next tayo guys. Okay guys, binary naman tayo to decimal. So, meron tayong 0, 1, 0, 1, 1, 0, 1, 0. Then, i-convert natin to into decimal. So, paano natin i-convert? Ganito lang guys. Itong 0 nakatapat ito sa 128. Itong 1 naman sa 64. Itong 0 sa 32. Itong isa naman sa 16. Ito naman sa 8. At ito naman sa 4. Ito naman sa 2. Ito naman sa 1. So, ang kukunin lang natin guys ay yung may 1. So, ang may 1 ay may 64. 64 plus the 16 plus 8 plus 2. Ito siya guys. Okay? So, 64 plus 16 is equal to 80 plus 8 is equal to 88 plus 2 is equal to 90. So, ang decimal ng binary na 0101111010 ay 90. Ganun lang kasimple guys ang pagkuha ng decimal.
Hi, our topic today is all about integers in computer. Integers in computer is a fundamental building blocks for representing and manipulating numerical data. In computers, we have four basic numbers. Number one is binary. And mayroon din tong tinatawag na base notation, and example. Sa binary, we have base 2 and the notation is 0 to 1. Example niya is 101101. Number 2, decimal. Sa decimal naman ay we have base 10 and ang notation is 0 to 9. Ang example is kahit anong number like pera, number ng CP, and etc. Like 09160. Base 10. Number 3. Octal. Ang octal naman ay we have 8 base and ang notation is we can use 0 to 7 only. Pero kapag 8 sa notation mo, that is not considered as octal. And then, ang example is 777. Base 8. Number 4 is hexadecimal. Ang hexadecimal naman is we can have 16. So meaning we can use number or letter Notations is A to F. Ang notation is 0 to 9. So basically, ang A to F and 0 to 9 is magiging example nito ay 2A. Notation, ang A to F ay magiging 10 to 15 pag numbers. Remember the four basics number system. This is the examples of binary to decimal version. 11011 base 2 equals Tapos, with the problem. One times 2 raised to 0 equals 1. 1 times 2 raised to 1 equals 2. 0 times 2 raised to 2 equals 0. 0 na 0 na yan. 0 yung ita-times mo. Then 1 times 2 raised to 3 equals 8. Ay, may nakalimutan ako, yung 1. Sorry guys. 1 times 2 raised to 4 equals 16. Then add, magiging together is magiging 27. Then copy. This is the answer.
My topic is about text data. So, let's proceed to text data. Once we have collected data from surveys or experiments, we need to summarize and present the data in a way that will be meaningful to the reader. We will begin with graphical presentation of data and then explore numerical summaries of data. Presenting categorical data, graphically categorical or qualitative data are pieces of information that allow us to classify the objects under investigation into various categories. We usually begin working with categorical data by summarizing the data into a frequency table. A frequency table is a table with two columns. One column lists the categories and another for the frequencies with which the item in the categories occur. How many items for into each category? So, let's proceed to data types. We have data types, categorical and numerical. For categorical, we have ordinal and nominal. For numerical, interval and ratio. A bar graph is a graph that displays a bar for each category, with the length of each bar indicating the frequency of that category. So, I have an example, a bar graph here. Example 5.2.2. Using our car data from above, note the highest frequency is 52. So our vertical axis needs to go from 0 to 52. But we might as well use to 0 to 55 so that we can put a hash mark every 5 units. In this case, our chart can benefit from being reordered from largest to smallest frequency and values. This arrangement can make it easier to compare similar values in the chart even without Garland like this. When we arrange the categories in decreasing frequency order like this, it is called a Pareto chart.
Error detecting codes are techniques using data transmission to identify and detect errors introduced during the process of communication or storage. These codes help ensure data integrity and reliability by checking whether the received data match the sent data. If discrepancies are detected, the errors can either be corrected or the receiver can request transmission. Here are some examples of common error detecting.
Para variety bit. How it works? Adds a single bit to data to make the number of ones either even parity or odd parity. Please refer to the picture for the example. Next sum. How it works? Adds all data values and the sum is sent as the checksum. This is also the example. This one is the CRC or the what we call cyclic redundancy check. How it works? Treats data as a binary polynomial and divides it by a fixed polynomial. The remainder is the CRC value. This is the example. Fourth one is the Hamming code. How it works? Adds parity bits to specific positions in the data to enable both error detection and correction. This is also the example. And finally, the Loon algorithm. How it works? Applies a mathematical formula to detect errors in sequences of digits. This is the example.
Repetition in general refers to the act of doing something multiple times of repeating an action. In mathematics, repetition can have different meaning depending on the context. Repeated operations. Multiplication as repeated addition and exponentation as repeated multiplication. Sequences and patterns. Identifying recurring patterns. Permutations and combinations. Handling repeating elements in calculations. Iterative process. Repeating step in algorithm until a condition is met. This is the formula. NR equal n factorial over n minus r times r. The combination of 5 objects taken of 3. 5 is n, 3 is r. 5r minus 5 factorial over 5 minus 3 times 3. This is the example of repetition. Expand 5 factorial to 3 factorial kasi our denominator, ang malaking given na factorial is 3 factorial. Kaya lumit ang value, cancel natin yung 3. 5 times 4 divided by 2 is 10 square.
Hamming code is an error correction system that can detect and correct error when the data is stored or transmitted. It requires adding additional parity bits with the data. It is commonly used in error correction code and RAM. Hi, in this video, we're gonna show how to find the uncorrupted bit in the Hamming codes. So, the question is binary 1 1 0 0 0 1 0 1 0 1 0 and 1. So first, let's put the blue line in parity 1, 2, 4, and 8. So we're gonna put these blue lines. We're gonna use these 4 numbers 1, 2, 4, and 8. So let's start this number 1. Let's check number 1, skip 1. Let's check 1, skip 1, check 1, skip 1, check 1, skip 1, check 1, skip 1, and check 1. So in this parity number 1, let's put question mark and let's copy 0, 0, 0, 0, and 0, and equal. Let's put this first number here, and then second the number 2. So, the same lang yung gagawin natin dito. So, check 2, skip 2, check 2, skip 2, check 2, and skip 2. So, let's put question mark again and let's copy the number 1. And always nating lalagyan ng question mark yung pinakaunahan dahil yung first number ay magiging question mark. So, let's copy 0, 1. 0 and 1. And is equals to 1. And next, let's copy here the quality 1, 2, 4, and 8. Next that we can do, let's see if this 4 answer is correct. So, number 1 is wrong because this number 1, the bits here is 1. So, number 2 is correct because the number 2 is the bit here is the same with this, and number 4 is wrong, and number 8 is check. Let's copy this 1 and 4 here and let's add them together to make it 5. So this 5 is from here. So this code means wrong. So this 0 is mapapalitan siya ng 1. So ikakopy na lang natin yung tamang codes nito. So number 1, 1, 1, 0, 0. So ito yung magiging wrong code. So papalitan na natin siya ng 1, 1, 0, 1, 0, 1, 0, 1.
Hello everyone, my topic is all about linear inequalities. A linear inequalities is a mathematical expression that compares two linear expressions using inequality symbol such as less than or equal to, greater than or equal to. So let's try example of linear inequalities.
Now, so let's begin by subtraction of 4 both sides. So negative 4, negative 4. And copy the 1/3 and x. And copy the less than or equal to. And 6 minus 4 equals 2. So let's put the fraction of multiply by side by 3. And 3 times 1 over 3 equals 1. So symbol is x. Copy the less than or equal to. Then 2 times 3 equals 6. So answer is 6. This is the example of linear inequalities. Both sides. 2x greater than or equal. So 5 minus 11 is 6. Then divide by 2. Copy the x, then greater than or equal, then 3.
Geometric linear programming, it is the actual application of linear programming and world problems
Tinatawag itong modeling. Real-world problems can be solved through linear programming. Before one can solve the problem through linear programming, it must be translated into mathematical equations. The mathematical translation called a model. Every linear programming has three components, which is the variables, objectives, and constraints. Variable are quantities that may vary in the problem. In linear programming, the objective can only be a minimization and maximization. Since the real world is finite and limited, the constraints need to be met in order to optimize. Next, the corner states that the maximum and minimum values of an objective function occur at corner points of the region of the possible solution if the region is bounded. So here is the steps to follow in using graphical methods. Number 1. Represent the unknown in the problem by using variables using any letter. Number 2. If necessary, tabulate the unknown data. Number 3. Formulate the objective function and constraints. Number 4. Graph the constraints and find the feasible. Number 5. Substitutes the coordinates found in the feasible region. Lastly, determine your solution by selecting the highest value or maximization, lowest value or minimization. We have here an example of actual work problem. Shinlin Electronics assembles stereo equipment for sale in their shop. It offers two products, turntables and cassette players. It makes a profit of 200 on each turntable and 400 on each cassette player. Both must undergo two steps, assembly and bench checking. A turntable takes 12 hours to assemble and 4 hours to bench check. A cassette player takes 4 hours to assemble and 8 hours to bench check. The shop has 60 hours available in assembly period of production and 40 hours of bench checking time. Determine the number of turntables and cassette players it must produce to maximize the profit. So, eto na siya ngayon. Nag-isip siya kung ang kikitain niya sa bawat turntables ay 200 at 400 naman sa bawat cassette players. Ilan ang gagawin niyang cassette players at ilan din ang gagawin niyang turntables, considering na ang limited time niya lang ay 60 hours sa pag-assembly at 40 hours naman sa bench checking. It means when you see the word available, ang ibig sabihin ay hanggang dun lang. Hindi po siya pwede sumobra sa 60 hours or 40 hours ng production time because that's the only time limit. So let's make a representation. Turntables is the representation of X and the cassette players is the representation of Y. As you can see in the table, in assembly, we have 12 hours representation of X and 4 hours representation of Y. The time available is 60 hours. In bench checking, we have 4 hours representation of X and 8 hours representation of Y. The time available is 40 hours. We have the profit for each turntable. We have 200 and 400 naman sa cassette players. The objective is to maximize, as you can see in the table. Maximize the profit 200 times turntables plus 400 times cassette players, or 200 of turntables and 400 of cassette players. Let's proceed to subject 2. 12x plus 4y greater than equal to 60. 60 is the time available. 4x plus 8y greater than to 40. 40 is the time available. So let's convert it into the equation. Number 1, find the corners vertices. A. 12x plus 4y is equal to 60. So let x equal to 0. So it will be 12 open parenthesis and 0 close parenthesis plus 4y is equal to 50. I mean 60. So let's divide 4y equal to 60. 60 divided by 4y is equal to y equal 15. So we have ordered pair
x equal to 0 and y equal to 15. The next one, let y equal to 0. 12x plus 4 times 0 equal to 60. 12 times divided by 12 equal to 60 divided by 12. We have x equal to 5. Ordered pair, x equal to 5 and y equal to 0. Let's proceed to B. 4x plus 8y equal to 40. Let x equal 0. 0 plus 8y equal to 40. xy divided by 8 equal 40 divided by 8 is y equal 5. Ordered pair is x equal to 0 and y equal to 5. Next, let y equal to 0. So 4x plus 8 times 0 equals 40. 4y divided by 4 equal to 40 divided by 4. Answer is x equal to 10. We have ordered pair x is equal to 10 and y is equal to 0.
The simplex method is a technique for solving linear programming problems by finding the optimal value that satisfies constraints. It's a systematic procedure that involves moving from the feasible corner point to another until the optimal solution is found. For example, geometric interpretation. The simplex method moves from feasible corner point to another until the optimal solution is found. Algebraic interpretation is a simplex method involves identifying pivot elements in a series of matrix tabulations. Efficiency. The simplex method is efficient because it doesn't compute the value of the objective. Historical development. The simplex method was devised in 1947 by George Dantigs, a mathematical advisor.